In this section of the course, we'll consider exoplanets. We'll consider their detection and discovery and the methods by which they're characterized. We'll look at the frontier of this subject, which is finding Earth clones nearby in space and the life that might exist on them by the detection of biomarkers. For hundreds of years, philosophers have dreamed of detecting other worlds in space. For dozens of years, astronomers tried to do this difficult task of finding the feeble reflected light from planets around other stars. Finally, in 1995, the search was successful, and now a burgeoning new field has opened up, excitingly exploring the detailed properties of planets around other stars. The thing that would seem simplest is the direct imaging of a planet around another star. But that's hard. A planet like the Earth reflects a billionth of the light from its star, and that light seen at a distance is projected incredibly close to the parent star. The technique that finally succeeded was an indirect method using spectroscopy. By looking at the spectrum of a star that has a giant planet orbiting around it, the tiny reflex motion induced on the star by the planet can be detected. It's very subtle, a few parts in 10 million or 100 million. But it was successful in finding giant Jupiters in close, tight, hot orbits around their parent stars. A great surprise, out of whack with our theories of how planets form around stars. Over time, more and more planets were found, with the detection limit passing through Uranus and Neptune-sized objects and heading towards terrestrial planets and super-Earths. The second technique that's broken open the subject, especially with the Kepler satellite, is the transit or eclipse method. When a planet orbits a star close to the equatorial plane, that planet will momentarily eclipse its parent star. The census of exoplanets has doubled essentially every 18 months, and now it stands at almost 3,000. Before 1995, the field didn't even exist. Now we are close to characterizing those extrasolar planets. Armed with both a Doppler detection, which gives mass, and a transit detection, which gives size, you get a mean density for the planet, and we can start to tell whether planets are gas giants, rocky, or perhaps even water worlds. Characterization of exoplanets is the next frontier, and the hope is of detecting biomarkers. That is, the presence of life by its imprint on a terrestrial atmosphere. At the moment, that's beyond our detection capabilities. Join us in this exciting discovery of a brand new field of science.